3.5. The standard normal distribution. As the 68, 95, 99.7 rule suggests, all normal distributions share many properties. In fact, all normal distributions are the same if we measure in units of size sigma about the mean, mu, as center. Changing to these units is called standardizing. To standardize a value, subtract the mean of the distribution and then divide by the standard deviation. Standardizing and z-scores. If x is an observation from a distribution that has mean mu and standard deviation sigma, the standardized value of x is z equals x minus mu all over sigma. A standardized value is often called a z-score. Statistics in your world. He said, she said. Height, weight, and body mass distributions in this book come from actual measurements by a government survey. That is a good thing. When asked their weight in a recent Gallup poll, 38% of respondents said they were overweight. However, a body mass index of over 25 is considered overweight, and the actual measurements from the government survey indicate that well over 50% are overweight. A z-score tells us how many standard deviations the original observation falls away from the mean and in which direction. Observations larger than the mean are positive when standardized, and observations smaller than the mean are negative. Example 3.4, standardizing women's heights. The heights of women aged 20 to 29 in the United States are approximately normal, with mu equals 64.1 inches and sigma equals 3.7 inches. The standardized height is z equals height minus 64.1 all over 3.7. A woman's standardized height is the number of standard deviations by which her height differs from the mean height of all women aged 20 to 29. A woman 70 inches tall, for example, has standardized height z equals 70 minus 64.1 all over 3.7 equals 1.59, or 1.5 standard deviations above the mean. Similarly, a woman 5 feet, 60 inches tall, has standardized height z equals 60 minus 64.1 all over 3.7 equals negative 1.11, or 1.11 standard deviations less than the mean height. We often standardize observations from symmetric distributions to express them in a common scale. We might, for example, compare the heights of two children of different ages by calculating their z-scores. The standardized heights tell us where each child stands in the distribution for his or her age group. If the variable we standardize has a normal distribution, standardizing does more than give a common scale. It makes all normal distributions into a single distribution, and this distribution is still normal. Standardizing a variable that has any normal distribution produces a new variable that has the standard normal distribution. Standard normal distribution. The standard normal distribution is the normal distribution n bracket 0, 1 end bracket with the mean 0 and standard deviation 1. If a variable x has any normal distribution n bracket mu, sigma end bracket with mean mu and standard deviation sigma, then the standardized variable z equals x minus mu all over sigma has the standard normal distribution. Apply your knowledge. SAT versus ACT. In 2018, when she was a high school senior, Linda scored 680 on the mathematics part of the SAT. The distribution of SAT math scores in 2018 was normal, with mean 528 and standard deviation 117. Jack took the ACT and scored 26 on the mathematics portion. ACT math scores from 2018 were normally distributed with mean 20.5 and standard deviation 5.5. Find the standardized scores for both students, assuming that both tests measure the same kind of ability. Who had the higher score? Linda had the higher score at 1.299 standard deviations above the mean, whereas Jack had the lower score at only 1 standard deviation above the mean of his test. Men's and women's heights. The heights of women aged 20 to 29 in the United States are approximately normal, with mean 64.1 inches and standard deviation 3.7 inches. Men the same age have mean height 69.4 inches, with standard deviation 3.1 inches. What are the z-scores for a woman 5.5 feet tall and a man 5.5 feet tall? say in simple language what information the Z-scores give that the original non-standardized heights did not. A man who is 5.5 feet tall is below the average height of men by 1.097 standard deviations, whereas a woman who is 5.5 feet tall is above the average height of women by 0.514 standard deviations. This allows us to compare the heights for men with the heights of women because the Z-scores are standardized.